Welcome. Thank you so much to everyone for taking the time today to join our webinar. This is Deploying a Cloud Observability Stack in Minutes with cPacket Terraform. My name is Trey Mozagemba. I'm the cCloud Product Manager here at cPacket. And we also have Martin Bright with us this morning, Senior Cloud Infrastructure Engineer at cPacket. Martin, you want to do a quick introduction and then I'll give one myself?
Sure. Welcome, everyone. My name is Martin Bright. I'm a Senior Cloud Infrastructure Engineer at cPacket. I've been at the company for 2 years, and I've been doing information technology and software development for probably over 20 years. But the last few years have been in mostly the DevOps area. So go ahead, Trey.
Yeah, thank you for that, Martin. And so I'm the cCloud Product Manager here at cPacket. My name is Trey Mozagemba, based in San Antonio. I've been with the company for about 1.5 years, and I've been working in some form of software development for the better part of 10 years. So let's go ahead and dive into the content for today. Really quickly, I always like to just start with a brief introduction on what cPacket Networks does, who we are, just so you have some context as we get into the main scheduled program, which is obviously our Terraform demo and all the exciting things that we have prepared for you guys today. But cPacket Networks is all about providing hybrid cloud observability for your enterprise. So you see along the bottom there, whether it's a branch, a head office, a data center cloud, or even a virtualized hypervisor type environment, the cCloud solution and really the cPacket line of products gives you this observability into these different regions, right? So we provide advanced network packet brokering, packet capture and analytics, and really wrapping all of that up with a single pane of glass management platform with our cClearV platform. Really quickly, just to hit on the cCloud products here at cPacket, we have our CVV virtual packet broker at the top there, which is our virtual packet broker, really allows you to reliably replicate packets to many tools. And in the middle there, we have the cStorV, which is our virtual packet capture platform. And it's all about continuous capture and performance monitoring in the cloud. It's some really cool advanced capabilities that our cStor platform can hit on. And then on the bottom there, we have the cClearV platform, which is all about a single pane of glass management and analytics. And we can do really cool things, like just an example of a powerful capability of the cClearV, right? It's a single interface, a single API interface into all of your cCloud deployed appliances, and even really all your cPacket appliances, I'll put it that way, right? So you can think about doing something like a single query where you have multiple cStorV packet capture appliances deployed in your infrastructure, and the ability to go query all of those various cStorVs from a single interface, and bringing that data into our cClearV platform, which also has a Grafana, visualization capability built in, et cetera. So anyways, there's just a really high level summary of our products, who we are, what we do. But let's get into the agenda for today, right? The reason you guys have all joined us. So we're actually going to go today through a real live Terraform demo. We're going to actually have Martin, I'm going to turn it over to him in a bit, and he's actually going to kick off this deployment. It's going to run in the background. We'll go through the slides, and we're going to actually come back and show you guys all the things that we've deployed in Terraform in a basically 10 minutes or less as we go through today's webinar. But at the top there, we'll start with the high level Terraform overview, just some basics, give you guys a little bit more context around Terraform before we jump in. Then we'll have Martin kick off the live Terraform deployment. Then we'll start talking about really why cPacket uses Terraform, why it's so important, the types of tools we provide to our customers, et cetera. We'll pivot back to our live Terraform deployment after that time. So we've had, it's had 10 minutes to run-ish, and we'll see all the resources in the AWS console. Then we'll move on to an overview of the cPacket cCloud solution, wrapping up, and then we'll get into the live Q&A at the end. So that's the agenda for today. So let's talk a little bit about why Terraform is important. Customers want it for the same reasons that cPacket does, obviously. But Martin, in your experience, what are the top 2 or 3 things on this list that stick out to you most in terms of the value that Terraform is providing?
Well, I think, all the things on this list are important, but probably the most important thing for customers is that it leads to repeatable and less error-prone deployments. It certainly helps with performance, but I think a lot of the impetus around infrastructure as code is about risk, and so reducing errors, making things auditable, having version control over deployments, and having a lot of clients also have CI/CD pipelines that they need to plug into. So that the whole infrastructure as code paradigm is what is the reason why customers do it. And we at cPacket, we also have many of the same concerns. So not just for the customer, providing the customer what they need, but also our internal development and testing.
Yeah, absolutely. And that's like really interesting. So we have actually some information on that. Like at cPacket, we use Terraform for deployment on our own cloud infrastructure, kind of multi-cloud deployments, testing and QA for increased automation, like Martin's hitting on. Like, we reap the benefits of this on our side from a development shop ourselves, right? So we are super aware of all of the real, the cool things that Terraform brings to the table in terms of like providing, ultimately, like you think about your deployment, right? And it's one thing to deploy something once, but it's really about like the TLC, right? Like the tender love and care you're given that deployment over time. And that's what's become so apparent to me working with Terraform over the last year, is just like how many benefits there are in that sense, in terms of just like how you think about caring for your infrastructure over time, right? So that's definitely really exciting.
Yeah, I mean, just to give you an example, yesterday I was I was giving a demo or walking through my team for a method of deploying, but I was using the web console in Azure, and we had, so it's obviously possible to deploy our solution manually or interactively through the web console as well as through Terraform, but I'd done this demo many times and it was working, and then I did it this time, and I forgot a step, just because it's more error prone to do things manually, right? Get the computer to do the work, and you have something less error prone. So, yeah.
Yeah, and whether it's like Azure or AWS, the console is always changing as well. So even if there is a step that you're likely to forget it when they change the UI. It's always a wonderful treat. So let's talk a little bit more about like just like the other obvious benefits of Terraform, Martin, like infrastructure as code. What is that? What do all these things mean, right?
Yeah, so infrastructure as code is really it's a simple but really powerful idea that's been around for a very, very long time. And it's the notion that you specify in code what you would perhaps otherwise do interactively. And so Terraform is just it hits the nail on the head. It's the hammer that hits the nail on the head here. It really, that is the purpose of Terraform. It's to enable infrastructure as code. And so what does that really mean, like at a kind of lower level? So, once you've specified your infrastructure as code in computer readable files, right? You hand it over to Terraform. And so, you have your configuration, it's fully specified. Then what happens? Well, what Terraform does for you is the sort of nitty-gritty of deployment. So the main thing in this list is sequencing. So the order of operations. And so, as a network operator or as a developer, you specify what you want instead of how you want to deploy it, right? It's a declarative way of deploying. So the most important thing here is sequencing. So the order of operations, and obviously that's, if you were to write a program to do this in Bash or Python, you would have to specify exactly how to do those things and the order that they would happen in. Whereas with Terraform, you just declare what you want, and the engine performs the sequencing. So that's like the main advantage here. But the other three things there are sort of related to like are really cloud specific. So I mean, they're sort of distributed systems focused. So if you have the demo that we're going to show later on has about 60 things that it has to deploy, and you can imagine doing those things sequentially would take more time than doing them concurrently. So again, Terraform saves the day there, and handles concurrency. And you'd have to, this is something you'd have to worry about if you were using a more basic tool. Yeah, so retry logic is also kind of distributed systems focused. It's, some things fail, like you have a network, it's not perfect. You're going to have to redo some steps. And so retrying, this is another thing that Terraform does for you. And then the last thing, idempotent is more, I think the best way to describe it is with a concrete example. So like if you go in an elevator and you hit floor 5, you expect to go to the 5th floor. If you hit the button again, you don't expect to go to floor 10. You expect to go to floor 5. So that's it. It handles that aspect of deployment.
Yeah, and like all of these things, right? It's like when you read sequencing, concurrency, retry logic, idempotent, it's like none of those things are like maybe the sexiest. Like, oh, that's getting you out of the bed morning, right? But like it's like, these are the devil in the details, right? These are the things that you have to worry about in terms of caring for your infrastructure, thinking about it over a long term, all the maintenance, all of the people involved. We'll get into like some of the collaborative benefits later. But yeah, so anyways, that's just a kind of high level on some basics around Terraform, why we use it, the things that we find are interesting. We'll certainly get into more of that as we get into today's presentation. So now we're actually going to jump into the Terraform deployment. We're going to actually have Martin run through in AWS, basically a Terraform deployment that we've prepared for you guys this morning. There's like 60 something resources that are being stood up with this deployment. It's pretty complex. Like you see there at the top, we're deploying all 3 of our C Cloud products that we talked about, the CVV, CStore, VC, ClearV. We're utilizing the AWS Gateway Load Balancer as a means of how basically traffic is getting to our CVV virtual packet broker for the purposes of packet replication. And then we're also creating and configuring subnets, VPCs, availability zones, all the bells and whistles in terms of setting up this actual monitoring network. And then we're configuring, security groups, IAM roles. And then we're even doing some stuff as far as generating some synthetic traffic infrastructure for the purpose of actually like, it's you can think about it, it's like, it's the value add that we bring is some of that is like testing tools and things that allow you to simulate this traffic in the cloud. Obviously, if you think about like an upgrade plan or something like that, it's important to be able to know, that traffic is reaching the tools before you switch off the other machines, et cetera. So, we have solutions designed for that, and we'll be deploying that as part of today's sample deployment. But with that being said, Martin, I'm going to turn it over to you to run through the deployment.
Yeah, can you see my screen?
Yes. Thank you.
Okay, perfect. Yeah, so here I have the AWS Cloud Shell, and I've uploaded the Terraform into my account. So you see there's a lot of files here. Don't be scared. It's just we've broken things down into small, easy to consume chunks here. So what you basically do is you have a directory full of Terraform files that define and encode all the, fully specify the infrastructure. And then over here, you just say init, Terraform init. I mean, anyone who's familiar with Terraform will be very familiar with this. But the other thing is, then you just do Terraform apply. And you, in my case, I'm approving immediately, but you would have plenty of chances to verify what you're deploying. We can get into that in a second, but I'm just going to run this, and then we'll see that it kicks off. And then about 10 minutes from now, the 60 odd resources and cloud objects will have been deployed. So off it goes, and I'll hand it back to you, Trey.
Yeah, absolutely. And just to give everyone the context again, we're running this in the background just to kind of actually prove that it's doing the thing. It's obviously not very sexy to go show the green screen scrolling through many lines of code. So we're going to turn away, run through some content here, and then we'll pivot back to look at the resources towards the end of the presentation. Before I jump back to the regularly scheduled programming, I do want to remind everyone, since we are live today, if you do have any questions, we are going to do a live Q&A at the end. Please post your questions. Feel free to bounce anything off Martin or myself that we're capable of answering. I don't know how much that is, but we'll certainly try our best. So please do post any questions that you guys have in the comment section, and we will try our best to get to as many as we can in the live Q&A at the end of the webinar today. Okay, so moving on. So why cPacket uses Terraform? There's certainly a lot of reasons that we use Terraform at cPacket, and we've already sort of touched on some of those. Martin, I'll let you run through this list, right? But why is Terraform so important here at cPacket?
Yeah, so I mean, all of the reasons that we discussed before are sort of the obvious, and perhaps those are the obvious reasons why we use it. But there are some things that that emerged when we started to use it that were really nice to learn about. And the first one there, declarative syntax, is kind of, that's the obvious one. It's like you specify what you want, know how to do it, not how to do it. But it really does free up the mind, and it sort of frees up the team to worry about other things. So, imagine you had a recipe and you had a list of ingredients, and then after the list of ingredients, you have to perform some steps. That this is what to do, right? Or this is how to do those things. But in Terraform, you almost have like an even more basic recipe where it's just a list of ingredients almost, and then the engine figures out how to do it. And it sounds like magic, but really what it is just about fully specifying what you want. And that actually leads into the next thing, which is it brings clarity to the actual requirement. And so, in our case, we have many different network topologies that we have to test and develop. And so what that does is it forces us to encode and specify those things. And it really helps in that domain, which I kind of maybe intuitively suspected to be the case, but it really proves itself out, right? When you actually go through the step of writing things into code, right? And the other thing is that it's a sufficiently flexible tool that you could write everything in Terraform almost, or you can separate stacks. And so we have different modules for appliances, for the network, for IAM, identity access management. Those things can be lumped all into one, but it really is sometimes helpful to separate those concerns, and not just for ease of management, but it's also because in some organizations, like at some of our customers' sites, some of those concerns are managed by completely different teams, right? You'll have a team that does identity and access management, and they'll set things up for a network operator a sandbox, essentially, for a network operator to work in. And then they have to take the baton and set up the network. And then you might even have a third level where they're setting up VMs and our appliances. So, Terraform allows you to be very granular, or sort of more general or all encompassing. Like, I think it had a bad rap a few years ago when I first encountered it, where there was this reputation where it had to take over the entire deployment. But I don't think that's true. It's just about defining what you want to do and integrating with existing infrastructure.
Yeah, no, I think that last point's like really interesting, right? Like the ability to be modular. Like when you think about an enterprise network where you have like tens to hundreds of VPCs and many accounts, and there's all these regions, it just gets very like there's lots of stuff out there, right? And when you think about having to deploy a monitoring network and actually getting visibility into what's happening into your network, it's all about how you can insert these things into your infrastructure. And that's why Terraform is the perfect tool, right? It's like, how do we gracefully insert this new thing into the infrastructure without obviously wreaking havoc on the existing infrastructure and the existing apps and things that are already in the cloud, right? So that is really, to me, like among the biggest benefits is how, Terraform really is modular, and you really can use it to insert things into an existing complicated enterprise deployment.
Yep. Yeah, we kind of meet the customer where they are, and it's not just because it's not just because the tool is flexible. It's also because by the way, a lot of customers use Terraform, right? Like they already have CI/CD pipelines. They already have ways to plug in Terraform. They use Terraform, so they're often very familiar with it. But that's like the customer, like when we use it here, just to continue on, it's like I said, the as code momentum, like everything is code. Like it used to be just infrastructure as code, and then there was policy as code, which was interesting as well, because then, the security apparatus and the sort of IT administration aspects are also handled in code, which is, it's in like a few slides ago, we had the bullet point auditable, right? Like you want to be able to audit and prove out a certain number of things about the state of your infrastructure, but also like your IT policies, right? You could specify that in code as well. So that's kind of cool. And, once you have things in code, it seems like, I mean, I love coding, so it might be obvious to me, but it seems like for some folks, it might seem like, why are we doing this effort? Well, it's like, once you have the code, you can apply all kinds of tools to it, right? And you can leverage a lot of automation to verify and enhance and audit, right? And that's a huge thing. So we're just we love that here. And the thing is, it's not just us, right? Terraform's been around for a long time. It's not like we're using some novel technology, and you can see it with like the amount of material on GitHub and Stack Overflow, and the sort of good answers that ChatGPT gives you. So or good-ish, but yeah, it's that's great, because it's not like we're the only ones doing in this. We kind of have, it's a great situation to be in, because we're speaking the same language as our customers in front of the same problems often, right? So not only are we in the domain of the public cloud, just like our customers, we can also speak the same language by using Terraform. And that's a huge productivity win, right? And we actually found that, not only that, like on my immediate team, it's really easy to collaborate and communicate with Terraform. Like we have, whether you are a novice or an expert coder, it seems like it's really easy to grok Terraform. And just last week we hired someone, and they were able to contribute like on day one, because they knew Terraform, and because it was sort of obvious what to do, right? So
that's among my favorite things. Like I'm a product manager, right? I don't write code. Like I've dabbled in code in the previous life, but it's like, that's not what I do. And like, I actually picked up Terraform in the last few months, and it is actually kind of crazy. Like, number one, how simple it is, especially if it's like a well-structured sort of deployment. But once I really understood like how important the configuration was, and like then I realized all we have to worry about is like the configuration, right? All the other noise kind of goes away. And that's a really simplistic way to look at it, right? From my simple product manager mind, but it's just like, it's so black and white in terms of how you can structure a Terraform deployment, to the point that literally non-technical individuals can make assumptions and still draw conclusions from like, a configuration file or anything, any kind of sample Terraform deployment. It's really interesting.
Yeah, and this way we can also, so it frees us up to do more other kinds of work. So we can characterize a whole bunch of other scenarios, just because we've dealt with all these other concerns, right? So it's a really and it actually not just inside our team, but like if we have to share with QA, it's a lot easier to collaborate that way.
Absolutely. And then the other thing, we came across this quote, Martin actually found this. It's like HCL is actually like HashiCorp language is the fastest growing language on GitHub, which is like, wow, like that. It goes back to the things that Martin hit on, right? Like there's so much Terraform that's out there. Like it's been around now for, I think it was in 2014 is when it kind of started, right? So it's been the better part of 10 years now. So it's just kind of crazy that how how utilized Terraform is in the industry. It's kind of mind blowing.
Yeah.
So as far as reducing complexity, like this is obviously pretty important, right? And like I know Martin from his experiences has done more in Bash probably than any other language. But like, how do you compare and contrast it with like Bash as an example, Martin?
Yeah, I mean Bash is the opposite and I'm not bashing Bash. It's really great, but Bash is, you have to specify everything. It's a procedural language, so you have to say what to do and how to do it, right? Whereas Terraform is declarative, so you just say what you want. But there's also, modern, there are some really nice things that that have kind of emerged from like more modern coding or more modern languages and more modern practices. So like you have things like Terraform format or Terraform validate is the easy one that just validates syntax, and that's always really good. But Terraform format is one of those things that sounds like a little bit mundane, but it's really it really helps because what it does is it makes all the Terraform sort of format the same. It formats everything the same way, and so when an engineer sees it, they are immediately familiar with the style, and so there are no debates about where to place a bracket or how to structure the code. It's all very it may not be everyone's favorite style, but it's the same. So you have the benefit of everyone having sort of looking at the same thing, right? And I think that was the Go language kind of started that. And then you see like in every language community does that now. The Python community, the JavaScript community, everyone does that now, just because it makes everything more readable and it makes newcomers more comfortable. So, and then
yeah, exactly. You think about resources moving in and out of an org, right? That's like the thing that huge benefit in that sense in terms of being able to standardize the code and it being that easy, like literally one command to format the code. It's pretty great.
Yeah, and obviously the Terraform plan, which is the step I skipped in my demo, that is a massive thing. So when Terraform was introduced, that was a huge win because we're just demoing here, but in production you always want to check what you're deploying first and have escape hatches right at pretty much everywhere. So in production you want Terraform plan. When we use it at cPacket, it's more like we want to test and develop. So I skipped it in the demo, but yeah, Terraform plan is a huge thing.
And I think that like I know Martin loves to code. I know you guys can't tell that by this webinar so far, but he does love to code, but he also loves his time, right? And I think that's one of the favorite things, or what Martin said was one of his favorite things about using Terraform is that it does save him time. So it's like you're spending more time doing important things rather than some of these repetitive sort of mindless tasks from a Bash perspective, right?
Yeah, it's some of these things are solved problems, or at least very concurrency, retries, sequencing. Those are things that are not solved problems, I want to say, but at least very familiar problems. And so why reinvent the wheel when we're doing that stuff, right? So we using something like Terraform lets us do more value-added work.
Absolutely. And then we talk about multi-cloud, right? Like maybe this is obvious, but like we just talked about like HCL, the HashiCorp language, like, the ability to have one platform to deploy across any number of clouds. We even have some Terraform that's like in VMware that we can provide customers. So it's like, it's one thing to understand, one thing as an organization we have to wrap our heads around. And then we have the ability to do all these, work across all these various CSPs. Now, obviously every CSP has its own rhyme and reason, and, some have certain features like traffic mirroring and some don't, but it's one language that we had to grapple with. And we're now able to work with it to deploy to any cloud. I mean, essentially at this point, like I would think any modern CSP provider, even like the little guys would probably have some kind of Terraform provider and the ability to deploy via Terraform, right, Martin?
Yeah, they do. Yeah, I mean, it's not just the big players. It's not just Amazon, Azure, GCP. Like, DigitalOcean has Terraform providers. Like,
Right.
it's amazing.
And then the pipeline, like, what do you think in terms of like what are the benefits from a pipeline perspective, like for multi-cloud? What do you think about that?
Yeah. So, so every provider in Terraform, the syntax for the provider is a little bit different. So think of it as more like, there's a little bit of a dialect when you switch clouds, but you're still speaking the same language. And so the integration with your deployment pipelines is intact. It's the same. And so even though you're speaking slightly different Terraform, how you plug into your system is the same. So that's a big win too, right?
Absolutely. And, again, I know we already kind of hammered this home, but like we leverage all of these benefits in our own infrastructure, right? Like we have to manage our software in all these clouds, like especially QA, like you think about all like the hundreds of scenarios we have to run through, like cross subnet, like east, west, north, south, like we have to do so many different things. And the ability to use Terraform and have one platform across any provider is just, again, hammering it home, but we really reap the benefits of that ourselves. So it's near and dear to us.
Yeah.
So now let's talk about like, how do we deliver Terraform, right? Like, how do we give Terraform to customers? I know I'll let you go, Martin, because you certainly have the most experience in this area. But obviously, example code is a huge part of how we generally get customers started with the POC, working closely with them to understand the infrastructure requirements, kind of shaping Terraform around the potential way they're looking to deploy or the way they're looking to insert our infrastructure into their infrastructure, right? But how would you describe how we give this to customers and provide the example code?
Yeah, so we deliver example code mostly for now, but we also have a CLI that has certain tools that generate some Terraform as well. So that helps the customer get through the specification of or writing out the Terraform. And we ship basically tar file with the examples in it. That's we can do that. We have GitHub repos, public, or we can even do we could share privately with the customer if they prefer that. And then we adapt the Terraform to what they need. So if they as we mentioned before, if they have if they handle the IAM part, they can just choose the networking part and the appliance part. So, or if they have a sandbox, or if they've earmarked a sort of or an account, even they could just do it all with our Terraform. So it allows us to, we have various different ways of getting the Terraform to the customer.
Yeah, and that's really well said. And like the important thing to remember, right, is there's no one size fits all. Like you're like, why is the example code? Like, what does that mean? Like, at the end of the day, every enterprise cloud deployment is going to be complex, and there's going to be some unique traits about this said particular, deployment, right? So, we have a variety of examples. Again, just think about all the different QA scenarios you could dream up from a packet replication and packet capture perspective, perhaps. So it's like, we had to really think about how we modify and have well-defined examples in order to get the best result, which is like, ultimately a sort of a unique solution to the customer, working with them to understand what are their Terraform needs and wishes, kind of thing. And then that third bullet point there in their example code, like this is something that's really interesting that we talked about, Martin. It's like, at the end of the day, it's like a Terraform script. It's like, okay, that's cool. But like, it really is bringing together like several business functions. If you think about it that way, like we talked earlier about, like you might have one department doing like IAM and another that's working on like more of the NetOps and like the DevOps in that sense. So, it's actually like one script that actually compiles things like IAM, network topology requirements, where appliances are being deployed. Like it actually crosses potentially several business functions. So it's really interesting because this all goes back to that notion of collaboration and like the ability to communicate the requirements across, again, whether it's like more of a role and policy sort of organization, or it's the organization that's responsible for literally deploying the cloud infrastructure. It's one thing that people can reference and all see the same thing, right? That's really interesting.
Yes, absolutely. Yeah. Yeah.
So just a quick quote from an industry Terraform user. I thought that was good that I found, and then we'll actually jump into the back to the demo for Martin to show. But this gentleman, he said that Terraform is the de facto tool for provisioning infrastructure today. He said, we use Terraform to provision all our infrastructure in all major cloud providers, AWS, GCP, Azure. We have invested a lot to make our code repeatable and scalable as we need to support multiple accounts in each cloud provider. This is like a lot of people's problem, right? Like in reality, if you're working with more than one cloud provider, now you're worried about how do you scale, how do you make things repeatable, how do you like less error prone, all those things we talked about, right? Like these are hitting home the reasons why people are gravitating towards Terraform and have been for, again, the better part of 10 years.
Mm-hmm. Yeah.
So now back to, I know you guys are tired of my slides now. So now back to Martin for the exciting stuff, which is to show us our Terraform deployment.
Yeah. So can you see my screen now? Yeah.
Yes, we can.
Okay, cool. Yeah, so actually this finished a while ago, well, like several slides back. So I should have put the time in there, but it was, something like 7 minutes or something. And so you see here, it says 63 resources were added. And then it gives you some output, which is, some things to, this is completely configurable. So you can, you can get some meaningful data out of it. But that's just the logging. But here, if you see in the AWS console, I have this. These are the machines that have been deployed. So here you see we have a single C view, a C clear, and a C store. So that's great. Those are our appliances. And then up here, these are all machines that are generating traffic. And so they're sending it here to our packet broker C view. And then over on the networking side, we have our cPacket monitoring network over here, but we also have the workload or the synthetic traffic. And then obviously here you can see some load balancers that were generated, and some auto scaling groups that have the C view and the C store, and then the web servers here. So yeah, it's really satisfying to see this stuff after it's deployed, and it was no sweat, right? Like it was a few minutes. I mean, 63 cloud objects added. That if you had to click through that manually, I don't know if you would be so happy, right?
It would certainly take longer than this webinar to do that manually. All right. Thank you, Martin, for running through that. Let's go back to our slides now. Okay, I think we're good. Just a reminder for anyone that has questions, please post them in the live comment section. We will get to that at the end of today's presentation. And really, just to kind of hit home on this Terraform demo, we were just trying to show how easy it is, right? Like, I mean, Martin had a little override command in there, but it was essentially Terraform apply, right? We went into we CD'd into a new directory, Terraform apply. Like we just chatted for a few minutes, came back, had your coffee, came back, and now you have 63 resources that have been deployed in a repeatable fashion. Again, you're like, why did we deploy synthetic traffic? It's like, because if you have a very complex infrastructure and you have things like packet replication and really business critical tools that are, you're relying to, you need the packets to get to those tools essentially from a security or a SecOps perspective, perhaps even like forensic use cases or compliance use cases. Like we enable you to be able to validate the infrastructure, which is something that's really cool that I don't think a lot of other industry players are actually doing. So on to cCloud. I'm just going to go through a few slides here just to kind of really shed a little bit more light on what is the cCloud line of products. Like what more can you tell us about cCloud, right? So we always start the conversation when you talk about cCloud with our CVV virtual packet broker, which again gives you the ability to replicate packets to more than one tool in the cloud. So you see the left-hand side there, this is a basic traffic mirroring scenario in AWS. You might imagine pretty elementary example, a couple different subnets there, and then we have sort of a subnet for the tools there on the right. But we're traffic mirroring, and you're limited to a single copy of a packet with traffic mirroring inherently. Currently, none of the big three CSPs, the ones that support traffic mirroring, that is, even have the ability to replicate that same packet to more than one tool. On the right-hand side, that's what the CVV is solving, right? We have VXLAN outputted streams of packets to out-of-band tools, or inline. In this case, they're out-of-band. But here you see the CVV is actually delivering the packets to three tools, which like an IDS tool, an NPM tool, and our own appliances, right? Like the CStore V, and then we have our CClear V over here on the side that's kind of doing the management and orchestration. But that's really where we always start the conversation when it comes to our cloud offering, right? Like, where's the value? Like, how do you get the packets to more than one tool? Traffic mirroring inherently has limitations. We help solve those limitations. And it's not just traffic mirroring, and I'll get into that in a bit, right? But it's just when we hit home on the importance of cloud packet brokering, again, how do we get packets to more than one tool? What's really unique about the CVV virtual packet broker is everything we're doing is totally agentless. We're not relying on agents. We have like dedicated VMs that are running in your cloud infrastructure. So there's no agents required. You can think about like agents, you have to create a whole overlay network. Like think about like all the things we talked about with Terraform, like simplifying maintenance and long-term care. Like imagine having to implement an entirely new agent network across, thousands of hosts and Linux machines and all these things. That's not our approach, right? We take a different approach to packet replication in the cloud, and we honestly have the industry-leading solution in cloud. And you can replicate, like when we talk about these 5 tools as examples here at the top, it's not just 5, right? Like we've tested up to 10, but it's really up to N number of tools with cool things that we've added, like auto scaling and the ability to kind of scale up our solution in the cloud elegantly. So again, I kind of talked about the traffic mirroring scenario a couple slides ago, but I'm going to kind of hit home on really the 2 main modes of operation for our CVV that are probably most relevant to people. So first is this traffic mirroring target. This is really what I showed a couple slides ago, right? Traffic mirroring is a service that's supported by AWS and GCP. It's not currently supported by Azure. When it is supported by Azure, we certainly intend to support it. But at this point, I don't know that there's a firm deadline for when the VTAP solution is coming to market. But traffic mirroring is, definitely an easy way to stand up packet replication in the cloud. The downside maybe with traffic mirroring is that at scale, it does get difficult. These traffic mirroring sessions can also be pretty expensive. And they're also like taking up some of the bandwidth from the E&I on the machine itself. So I'm not saying traffic mirroring is a bad solution. It's actually a perfect solution for many customers. There's just sort of a pros and cons analysis you have to go through in terms of perhaps what's the best way to deliver packet replication in the cloud. And that brings me to inline routing. So this is also AWS. And what's unique here is that there's a gateway load balancer here that you see, which is what's unique about this diagram. On the previous diagram, it was just a standard network load balancer. But in this example, what happens is you deploy what's called a gateway load balancer endpoint, this little blue circle here, in the subnet that you want to basically obtain visibility from. And then we essentially sit in line in the data path. Like we're a bump in the cloud, if you think about it that way. And basically the traffic is passed to the gateway load balancer where it's processed, passed to our CVV appliances. And then, we make a copy of the packet and then we return. The traffic basically goes on the return path to the original destination. So there's a little bit of like an ebb and flow effect. And so there are things that happen, like there's minimal latency that's introduced just inherently by how we're making a copy of the packet and things like that, right? And that's why I go back to, it's just understanding like what's best for your infrastructure. Is it tens or is it hundreds of traffic mirroring sessions? Is inline a concern? Are we sitting behind a firewall? Is the traffic decrypted? Like all of these things come into play, right? But just at a high level, we have traffic mirroring and we have inline mode for how our CVV is able to obtain packets and then replicate those packets reliably. And then to speak about Azure really quick, because I did just go through a couple of AWS examples. Again, because Azure doesn't support like the VTAP solution, like I mentioned, everything we do today in Azure is that bump in the cloud approach where we're sitting in line in the data path. So again, there's that ebb and flow effect. The traffic is passed to our CVV packet brokers, The traffic is passed to our CVV packet brokers, and then it's returned back onto its original destination after we've made a copy of the packet. And all of these tools that you see here are sitting out of band. So, it's reliable. And that's really Azure. And then lastly, just to conclude, I always like to show this slide. Like, it's really just to kind of hit home on the power of the cPacket platform. So on the left-hand side there, you see sort of our data center products here, the cView, the cPro, the cStore, right? And then you also see a cStore V and a cVV up here, which is like a VMware scenario, right? So we even do like private cloud VMware, which is really cool. So you can think about this as your data center over here on the left. And on the right, we have the same products, right? We have our cStore V, cClear V, and cView V in the cloud. And really, what this picture is really trying to show is that we have this one single pane of glass management platform here, this cClear V, which is giving you visibility and access. Again, I talked about like the unified API and all the benefits of sort of a unified infrastructure, right, into a single ecosystem, single pane of glass visibility tool, which again has a built-in Grafana instance and has really the ability to give you capabilities that you can't get elsewhere with this type of ecosystem deployment. So again, I just like to show this because it really does hit home on the power of the platform. And again, we can help you. I know I've talked a lot about cloud today. That's all Martin and I have talked about. But certainly we have a really interesting solutions on the hardware side as well. 100 gig packet brokers, 100 gig port packet brokers with smart ports, FPGAs, ASICs, all the things, all the bells and whistles that we'd love to talk more about to our customers. But with that being said, I think we are now reaching the end. So I think we have time for our live Q&A. Let's kick this off. All right, and I do think that we had at least 2 questions come in that I saw, maybe more. Let's go ahead and see if we can get the first one on the screen. Okay, in light of the continuous evolution of cloud-native technologies, is cPacket observing any initiatives from AWS CloudFormation to support specific AWS resources that might not be currently available in Terraform? And then part 2 is, how are you leveraging these advancements using Terraform in your solutions? Have you found this to be a drawback at all?
So yeah, like I guess one of the things about Terraform is it's always slightly behind the cloud provider, the CSP, right? So if AWS has new objects in the cloud and provide CloudFormation for those objects, Terraform has to then incorporate it into its code, and so that there's always a little bit of a lag, but it's really not that much. So so we haven't had to do too much. We actually, I can't think of a single example yet where we've used CloudFormation instead of Terraform. We've had to drop down to, bash and do other things so it's not a perfect abstraction. Nothing ever is, but so yeah, there is that lag, but at least in my experience, the Terraform catches up very quickly. So yeah, it's a problem, but it's so far hasn't been a huge problem.
Yeah, that's a great question. All right, I see some more questions. Let's get the next one on the screen. How does cPacket license the cloud appliances? Is it per instance, or how does it work? That's a great question. I'll take that one. So our cView and cStore V products are based around a concept of volume-based licensing, or what we all commonly kind of refer to customers as a terabytes per day model. So we are looking more at sort of really, if you think about it, the consumption or the volume of data that's traversing our packet capture and packet broker appliances on a daily basis, and kind of evaluating on a daily basis. So we evaluate the actual number of bytes as opposed to doing more of a rate, which is something that we previously have worked with. But in today, when we sell cloud products, we are talking about terabytes per day in a volume-based licensing model. And really what that allows you to do, so you asked a question about the instance. What that allows you to do is deploy any number of instances that you want. Our license doesn't limit you to just one cView broker or 2 brokers. Again, we talked about inserting these things into your infrastructure, right? what this allows you to do with this consumption-based model, or this volume-based model rather, is to insert these brokers and insert packet capture appliances throughout your infrastructure, whether it's in sort of different sort of VPCs and things like that, perhaps even different regions, right? You have to kind of think about your monitoring holistically. But what the volume-based model allows you to do is to deploy any of those number of instances, and then simply have to worry about the actual traffic or the bytes that are passing through the appliances. So that's why we've taken that approach. It is somewhat standard when we talk about packet brokering in the cloud. And there's many reasons that we've kind of moved to that model. And I'd be glad to chat more about that particular question offline if you had any further insight on that. And I do see one more question that we have here. Let's see, you talked about packet mirroring and inline. Does your variable Terraform support both options? So yes, like at a high level, what I can say is that, again, I talked about, traffic mirroring as an example of a feature that's not necessarily supported by all the big three CSPs, if you will. So we definitely have to choose, where we support certain features as CSPs bring them to market. But AWS is the best example in that we have both the inline and the traffic mirroring scenario as an example. And yes, we do have Terraform, lots of Terraform scripts actually that kind of help customers along their journey to deploying those types of monitoring networks. And then also on Azure with, the inline approach, which is the only mode currently, we also have Terraform that aids in that as well. Anything else you'd add to that, Martin?
No, you covered it pretty well. I would just add that in AWS, as of this summer, the gateway load balancer can handle both traffic mirroring and inline modes. So that's pretty cool.
Yes, exactly. And yeah, I mean, I'd say from a development perspective, that's a really good point, Marty. It's like from a development perspective, we're trying to keep the parity as much as we can as, again, these CSPs are bringing features to market. But yeah, the gateway load balancer is a really cool technology that we're leveraging because it does support really sort of a hybrid approach of those two modes of operation. And with that being said, I think that is the end of the questions. Just want to thank everyone so much today for taking the time. You see the QR code on the screen there. Please scan and do follow us on LinkedIn. We'd really appreciate it. We have another webinar coming up in the next 30, 40 days. And I'm sure that folks will be excited to join that as well. But again, just thank you so much for taking the time today to join Martin and I on our journey through cPacket Terraform, and hope you all have a great rest of your day. Thanks, everyone.